Hello, my name is Alexander, and today I'll be going over our mini shell project with two of my teammates. So the majority of the code was done in eval, which basically evaluates whatever command line the user has provided to the shell. So first things, we parse line using the argv, and we get the argc, which is the argument count. And this helper was provided to us, and it basically returns a list of strings in argv. The next thing, we check if the user has provided us with a built-in command, and then we send, if this is true, we send it into our helper, which takes care of the next steps. Next step is to check which state we're going to be working at, and if the ampersand was provided to the command, we are going to be working in the background, and in the other case, we're going to be working in a format. Before forking, we need to be blocking all the signals, and if this was given to us in the assignment and the hints, and this makes sure that the child itself is also blocking the signals, and so does the parents. And later on in the code, they'll be unblocking the signals as we're doing our things. And the way we decided to design our eval is to send helpers if we have pipes or input-output redirection. And this for loop basically checks if we have a pipe, so we can use the respective helper, or we have the pipes. And this for loop basically counts the number of pipes and the number of input-output redirections. And my colleagues are going to go over the helpers for input-output redirection and the pipe. So in the case where there are no input-output redirections or pipes included, we're going to just be calling fork and then error checking for it. And so remember that before this, we had all the signals blocked. And so first things, in the child, we need to ignore the second, sig child, and sig stop. And this is because it was provided to us in the hint, and it's because we haven't changed the group ID of the child yet. And so we ignore everything that has been sent from the parents because, well, we need to change our group ID first. And we unblock the signals, and we set the group ID. After the group ID is set, we let the parent know using the SIG-user1 signal. And after this, we are free to stop ignoring whatever we were ignoring at the top. And then we change the signal handlers, basically. And then we call the exec to execute the program that the user was asking. If we're in the parents, first we make an empty set. This is going to be used later. And we check if we were in the foreground job, and then we add the job. Also, we also add the job if we're in the background. And either ways, we're going to be calling sig suspend. And this is because we want to suspend the process with an empty set and wait for the child to, or wait for the parents, basically, to receive any signal. And the signal is going to be user1, and we want to wait until user1 is sent to the parent. And whenever the user1 is sent, process is going to continue, and then we're going to unblock the signals because they were blocked in the beginning. And if we're in the foreground case, we're going to be waiting in the foreground. Otherwise, we're going to be printing whatever the command was and whatever the job the user wanted us to do. Built-in command helper, we list the jobs. If the provided argument was jobs, we are going to exit the program with the exit code of 0 if it was a quit, and we're going to call do background foreground if it was either background or foreground provided to us. In do background foreground, we have two cases. Well, if it was a background or foreground. So if what we want to send, what we want to turn into a background, we're going to be in this case, and we check if the first argument of the second element is a percentage, which shows that we are using the job ID of the process, and we're going to turn it into an integer. These are all basically error checking, and we're going to get the job using the JID, and this is error checking as well. And if we're already at a background, remember that this is a case for background, we don't need to do anything, and we just return. But else, we need to send it the sig cons, which was provided to us in the assignment, and to the negative job PID, basically, which is the job, like basically the process ID. And we turn the job state into background, and then we print the things. In the other case, we are using the PID and not the job ID, and the logic is basically similar, and the structure for the foreground is also similar, but we need to make sure that we're waiting for the, we call wait foreground since we're turning something into a foreground job at the end of our functions. In the wait foreground helper, we needed to make sure that the foreground process finishes before we enter the process for the parents. And so basically how we did this is while there is a foreground job, which is done by this helper and equals to the PID, which is basically the PID of the child that needs to be finished, we suspend the current process, which is technically the parent process, up until this while loop is false, basically. And so this makes sure that the child always gets finished first if it's in the foreground. So in our signal, the way we implement it is that we call wait PID with a parameter of -1. And this means that the parent process waits for any of the children, and no matter what the PID is. And the reason we did this is because when a sig child is sent, we don't know exactly which process it has been this caused this sig child and like what was the exact status. So we call this in a while loop, and we set the parameter to change child, and the wait PID basically returns a PID of the child that has been changed, basically. And in our if conditions inside our while loop, we basically delete the job if it has been terminated successfully. If it has been stopped, we print that it has been stopped by the following signal, and we change the job state. And if it was terminated by signal, a normal signal, we're going to delete the job, and we print out that it has been terminated by the following signal. And also, the other cases indicate that an error has happened. In our second handler, we first get the PID of the foreground process if we have a foreground process, and if the state is ready, we send the kill using the negative PID of the foreground process. We kill in the second signal. Now that this ready variable is to make sure that the child in the foreground has already changed the group ID, and so we can send the kill nicely. And in the sig stop handler, we do the same thing. We first take the PID of the foreground process. If we have a foreground process running, we send the kill stop with a negative PID.
Alright guys, so I'm going to now show the pipes, how the pipes work in our file. And now we have the whole code right here, but just for demonstrating purposes with an example, I'm going to copy this code on my iPad and show how the code works with an example. So here we have the code. Okay, so I have made 4 processes here with pipes in between, and I'm using 2 pipes for this purpose. So first of all, we have a for loop, which basically counts the number of pipes we have. So we have a counter right here. So in this case, there will be 3 pipes. And then, so the number of commands will be counter plus 1. So 3 plus 1, 4. And we can see we have 4 processes right here. Okay, so what we do is we create 2 pipes, and now we for loop through for the number of commands. And in each for loop, we have a while loop, which basically splits the commands up. So it will look for the first pipe, and up till the first pipe, it will take the string, and this will become our first process, so which is handled by this while loop. And now we get to our main interesting section of the pipe. So basically, this process will take input from the standard input and write to the writing end of pipe 1. And once we get to this process, which is process 1 in this case, now this should read from the reading end of pipe 1 and write to the writing end of pipe 2. Note that we cannot write to the writing end of pipe 1 because we are reading from pipe 1 in this case, because this process wrote to pipe 1. So if we are reading, we cannot write to it. So that's why we need two pipes. So once we get to this process, now this should read from pipe 2 because process 1 wrote to pipe 2. So this should read to pipe 2 and write to pipe 1 because now pipe 1 is empty basically. So that's how this alternate thing works. We keep changing between pipes based on odd or even. So if it's an even process, we read from pipe 2, write to pipe 1. If it's an odd process, we read from pipe 1 and write to pipe 2. And all of this is basically handled by all of these if conditions, and we close the respective ends. So for example, in process 2, if we are reading from pipe 2 and writing to pipe 1, so we don't need to write to pipe 2, so we close the respective end. And similar for odd process number. So all these if conditions handle that. And how we are redirecting is basically using DOOP2. So any standard input output, it will redirect it to the pipes. And here we have the exec VP for each command. So it can execute the command under each child. And in the end, for the parent, we close all the ends of the pipe. So that's how our piping works using two pipes.
Hello, my name is Omar, and I'll be walking you through the input and output redirection in our program. So just to give a brief overview, our shell currently supports input and output redirection. So what does this mean? So let's say we encounter something like this. So we have two commands. What this is saying is take the output from command 1 and pass it in as input to command 2. And then we have a second case where we have something like this. And this is redirecting the input, so the output from command 2 will be the input to command 1. So first things first, we define a few variables like redirect, input redirect, and output redirect. So redirect will count the amount of redirections that we have, which are like these symbols. Currently, by the guidelines, we're not supporting more than 2 redirections. So we begin with a for loop. We're looping over argv, which is the arguments that we've encountered in our program, as Ili explained. So if we encounter output redirect, we'll set that to 1, and we'll increment redirect. We do a very similar thing for input redirect. Now, as I just mentioned, if we encounter more than 2 redirects, then we'll just return, as we're not supporting that. If we have more than 1 redirect, but less than 2, we'll go into this if statement, and here we're handling both cases, so single and double redirections. So now let's go over our function that handles the redirection. This does it for both single and double. What I mean by that is if we encounter something like this, we're having a double redirection. So we're redirecting the output from command 1 to command 2, and then redirecting the output from command 2 to command 3, and we can have that for input redirection as well. Right. So first things first, we'll fork, and then in our child process we initialize pointers for our files, and then we'll loop over the command line arguments. So the same argv list that we had, and here we're just setting up the files. So if you've noticed, if we encounter something like this. Something like this, right? So generally the first thing will be a command, and this will be a file, right? So if we encounter this in our argv list, that means the next I+1, like let's say this is I in our argv list, then I+1 will be the file. And since we're supporting more than 1 input and output redirections, we'll be having basically like 2 variables for each. Okay, so after that is done, very similar for both input and output. We're just setting up the files. And now we'll talk about handling the double input redirection. So the first thing, we'll open the first input file for reading, and we'll do some error checking, and then we'll set up the file descriptors. So the file descriptor is going to be set to standard input, and then we can safely close it, and then we fork again to create a second child, and in the second child we're executing. So the idea is we have something like command 1, command 2, command 3. The idea is we want basically like this to finish, and then when this is finished we pass the output of this as input to this. But we need to wait, because we need to wait for this to be finished before we can start executing this. I hope that is clear, but that's pretty much the general idea of why we need to fork. So after that is done and the second child finishes, we do a very similar thing. We open the second file for reading, set up the file descriptors, and we're done for that case. Now similarly, this case is very similar to the double input redirection. So double output is when we have something like command 1, command 2, command 3, and in this case as well we'll need to fork. We'll need to fork and wait. So we were first opening the first output file for writing, and then we'll duplicate to standard out. And then we can close the file descriptors, and then we fork again as I explained in the first case. So after we fork, then we can execute the command, and then again we have to wait for that to finish before we can redirect the output for the second file. So that's the case for the double output redirection. Now here we're handling single input or output. So if we have an input, so yeah, here we're handling the separate cases, so separate single input or single output redirection. So if we're having an input redirection, we'll open the input file for reading, duplicate, and then this is for the input redirection. It's a very similar thing for output, except we're opening the file for writing now. And then we can safely execute the command, and we know we also work because we have set up our file descriptors correctly for the inputting and outputting. Then here we're just having some error checking. So if the PID is less than 0, this is checking for errors that we encountered if we fork. And then we wait for the parent process. We wait for the child processes to finish, and then we can safely return as we know that by then we'll have finished the command.
Okay, hey guys, so my name is Harshimar and I'm going to show the testing for our assignment for our group. So first of all, I'll show the compiling with the GCC w all w error. So we see that it worked without any errors. So now I have opened two terminals here, so I can show our test files here and the R test, the reference test here. So I'll start with make test one, make R test 1, and so on. Okay, so up till now we saw that every test file has matched in both terminals, in the reference file and in our test cases. And now I'm going to show the last test file, which is the input-output redirection. And we can see that that also is the same. Okay, so now we're done with the supply test cases. So now basically I'm going to show you our own test cases that we have created for this assignment. I'm going to show them right here. So, okay, so my first test case is this one. Okay, so this test is basically printing those lines which contain the word hello. So basically it should print hello world, but not world, because grep ensures that the lines which contain hello should only be printed. And we see that hello world was printed here, so this test passed. And now I have another second test case, which is this one. Now this is basically my own personal created 3 files. So testing 1, this file prints this. This is the output of program 1. This takes in standard input, but because of the pipe, this will take in the output of program 1 and it will print it here. And testing 3 will take that whole thing and print it here. So let's see what it's printed. And we can see clearly it printed correctly. Program 3 received input, program 2 received input. This is the output of program 1. So that test case worked as well. Now for our third test case. So for our third test case, we have that we'll create 2 files and echo this test file 1, test file 2 to checking in both of these. And then we have multiple input redirection. So we'll concatenate both of these files and print it. So it should basically print, this is test file 1, this is test file 2. And we can see that happened. Okay, so now I'm going to make our test case 5 because that's necessary for the to creating the files. So here, this test will basically echo hi, how are you to both of these, hi.txt and hi2.txt. So this handles multiple output redirection. Okay, there we go. And then we can check if this was written or not, nano. And we can see that it was written. We can check for the other one as well. There we go, same thing. And now we do the last test case, which is make our test 4. So this test case handles redirections with different redirections. So this thing should take the hi, how are you, and put it into checking.txt. And this thing should take this is test file 2 from checking2.txt and put it into hi.txt. So we can try nano hi.txt. Okay, this contains this is text file 2, and we can do the other one checking.txt. This contains hi, how are you. So like that, I've showed our personal made 5 test cases. So that's it.
Hello, it's Omar again, and I wanna touch up upon some of the challenges that we faced with this assignment. So the first challenge that we had, the main challenge that we had, was the operating system that each of us were using. So Ilya was on Windows, and he faced a lot of issues. Sometimes he couldn't even compile the program because he was using Windows, and it was something related to the signals, like he was just getting errors. And then me and Simmer were on Mac, so we could run the assignment and figure some of the things out, but Ilya couldn't because he was using a Mac Windows machine. Similarly, like we had an issue where let me get to it. So right here, when we're checking whether to run our command in the background or the foreground, if we encounter an ampersand and then we run our command in the background, what we had before was this. So we set the last, because the ampersand is the last argument in our RV list, we just set it to null, so then we can actually execute the command, because we weren't recognizing null as a command when we're executing. The issue was, if you notice, we're not decrementing the argument counter, which caused a lot of debugging. Spent a lot of time debugging just for this small mistake. And on our Macs, when we ran the program, we were getting broken pipe 13 when we ran test 7. which was, it was really hard to decipher and figure out what that means. And when we ran it on the lab machine, we were getting, segmentation fault. So it was really tough debugging such a simple issue, just forgetting to decrement the argument counter. This caused like memory leaks and stuff. Now, another challenge that we faced was with the input and output redirection. So